Alright, so let's get that function on our calculator. I asked you guys to put in that, so let's put that in. Clear 5x cubed minus 10x squared minus 20x plus 7, and then to put our standard viewing window, it is zoom what number? Standard. This is your crazy looking graph. But your graph has too much on these sides and not enough on the y max and not low enough on the y minimum. So you press window. Erica, what did you change on here?
The y minimum and the y maximum.
Okay, what did you put?
40. I did 40 and 30.
Let's see if this helps. Press graph. Okay, this is better. Do you see what it did? We went further down and further up. Notice how your y-axis is kind of thick, so from there, notice how if the difference between this is 80, you could probably count by tens. And what that does is now you can see the tick marks. So Erica is going in the right direction. Jose, what did you change on the x values? So, Jose, we want to not have, here is, my pen is showing x equals negative 10. I don't need as much. So if I kind of trim it to this part, which would be what? Negative what? Okay. And how about over here? Let's try it. He says negative 5. Remember, that's not subtraction, that's the negative sign that's next to the decimal on your calculator, way down here. Make sure you're using the negative sign, or you might have invalid dimensions. Check. That's better, isn't it? Now you can see that, class, this is called an a relative what? Relative maximum. It's not an absolute because the graph keeps going higher. This would be called a relative or local minimum. It's not an absolute because this keeps going down. Okay. So this is one way that you can change the windows and give yourself a visual. Here's another way you can do that. Watch this. Press second, trace. Now, you could guess by values, but you can actually calculate the minimum. So go down to number 3. It says left bound. So remember, we clicked on minimum, right? So this would be a wrong one to calculate. So there's my minimum. I'm to the left of the turning point. So if I put my pen where the turning point is, or the valley is, when it says left bound, I just want to be on the left side. Press enter. And then go to the right side. And then once a guess of what you think the minimum is. Now, it actually calculated it for us. Negative 2, comma, negative 33 is our minimum. Let's go ahead and calculate the maximum. Class, what should I press? Second trace. Now what? 4. Class, is my cursor on the left side of our maximum? No. So this is where you're just going to move it. Yours will actually, if you have a TI-84CE, you actually have a line. Is that right? And a color? Mine doesn't have that. It just has a little arrow. And you press to the right, and then you guess exactly our maximum. Press enter, If you ever see the dots on the side over here, they are calculating. So about negative 2/3 and about 14.4 is our maximum. One last thing I want to show you. So we've been learning about Vang, our mathematical modeling, and we have a graphical. You have the algebraic and the equation, and then you can also use a table of values. So let me show you how to use a table of values. Let's change our table set. Second window. Make sure they are on auto. You can change this to maybe like 1 and 1. It's saying I want my table to start at x equals 1 and I want to increase by 1. Press second table or second graph. And you can see that in the y values, that is the lowest point. Does that make sense? And then I'm looking for the highest point, so the biggest y value. We already knew what the answer is. What was the answer? Class, what did we say? That's getting too high. It's going to the left. But you can kind of see that it is a local by just being the biggest number in the area. We said something about like 2/3 between negative 2/3 between 0 and negative 1. Okay. So this gives you an idea how to calculate using your graphing calculator.